All right, so sorry my dog started barking in the background if you can hear that, but anyway, let's go ahead and finish this up here. Let's try and get through the rest of this 4.2 here. So let's go ahead and start with finding terminal points for basically for angles that are greater than, or that have a magnitude greater than 2 pi. And so we're going to find sine, cosine, and tangent for each value of this. So let's look at 9 pi over 2. So the way you're going to want to do this, or at least the way I do this, is to simply start subtracting 2 pi's until I get to a number less than 2 pi. So I'm going to just start subtract 2 pi until, so just keep repeatedly until you get an angle that's going to be less than 2 pi. And that's how we can find where the terminal point will be. So if we look at our unit circle here, do a quick little sketch. For this one is 9 pi over 4. So you have to go a bunch of pi over 4s, but essentially what we're going to do is do 9 pi over 4, and we're going to take away 2 pi. That's going to give us 9 pi over 4 minus 8 pi over 4, which is just going to then equal pi over 4. So essentially this first 2 pi that we took away, it means we have to do one full rotation. So we're going to do one full rotation, and then we have this pi over 4 left over, which means, other than that I just drew that one. No, I didn't. Sorry, put those back. We're going to go then another little extra pi over 4 amount. All right, so we did a 2 pi, and then we did another pi over 4. Okay, and then this other part was a 2 pi rotation, which is what we had. We had the 2 pi and the pi over 4 right there. And that gets us over to our terminal point, to our pi over 4, which is right here. And at pi over 4, our coordinates are square root of 2 over 2 and square root of 2 over 2 from that last video, which means we can find sine of 9 pi over 4 is just going to be square root of 2 over 2, and cosine of 9 pi over 4 is going to be square root of 2 over 2, and tangent of 9 pi over 4 is just going to equal square root of 2 over 2 divided by square root of 2 over 2, which is just 1. All right, for the next one, I'll do one more and then I'll leave the last one for you. We need to do 17 pi over 3. So we need to start subtracting 2 pi's. So let's do a minus 2 pi, and we'll get 17 pi over 3. Sorry, my handwriting's getting bad. 17 pi over 3 minus 6 pi over 3. That gives us 11 pi over 3. That's still greater than 2 pi, so we got to do it again. 11 pi over 3. Remember, every time we subtract a 2 pi, it means we have to do one full rotation. So we did one full rotation, but we still have another one we have to do. So this will become 11 pi over 3 minus 6 pi over 3, which will give us 5 pi over 3. And 5 pi over 3 is actually less than 2 pi, so we can stop. That's less than 2 pi, so we're good. So that means that we're going to have to do rotations of, we're going to have to do a 2 pi rotation, another 2 pi rotation, and then a 5 pi over 3 rotation. So what that's going to look like here is, here's our unit circle, quick little sketch. We're going to do a 2 pi rotation. That's going to be a 2 pi rotation. Then we're going to do another 2 pi rotation, and then we're going to do another 5 pi over 3, and so that's going to take us to pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3. That takes us right down over to here. That's a 5 pi over 3 rotation right there. And that takes and sets us up right here. This is one of our 60-degree or pi over 3 rotations, right? We had to do a pi over 3, a 2 pi over 3, a 3 pi over 3, which is just pi, a 4 pi over 3, and then, 4 pi over 5. I wrote 4 pi over 3, and then here we're at 5 pi over 3. So this has coordinates that are going to match with the pi over 3. And so pi over 3 has coordinates. If you look at this, just draw that straight down. We're halfway across the x-axis, so that means it's 1/2 for x, square root of 3 over 2 for y. And so when we come down here to do it, all we're going to do is just in this quadrant make the y value negative. So the coordinates there are 1/2 and negative square root of 3 over 2. So we have the coordinates of our terminal point, which means we can do sine of 17 pi over 3. That's just going to equal the negative square root of 3 over 2. Cosine of 17 pi over 3 is going to equal just the x value, that's 1/2. And then the tangent, we can do tangent of 17 pi over 3 is just going to be negative square root of 3 over 2 divided by 1/2, which is just going to be negative square root of 3. And so I will leave this last one for you to try. Just keep in mind that this one is negative, so you're going to go and rotate counterclockwise as you do it. Okay, let's take a look at trigonometric functions of an angle. Here, notice that our domains here basically is, we can basically put in anything we want. We can put in anything from negative infinity to positive infinity for sines, cosines, and things like that. But now we're going to start really actually talking about this with our typical angle measurement, which is theta. And it's our radian measure now. We're getting back to that. And so if you look at this, we have basically all the results that are going to occur as you go through this. We're going to have real numbers. If we have t is 0, that's a 0 radian or a 0 degree. And then here are the sines and cosines things. Now, this is not a table that I'm recommending that you memorize, because all of this should be stuff that you can figure out and just kind of solve from there. So don't go through trying to memorize this table. You should be able to just use the unit circle. That's what you want to get good at. You want to get good at sketching that unit circle and then being able to use it to pick out the values and fill this out. So you want to kind of get to the point where if I asked you to, you could fill this entire table out just by sketching out the unit circle and filling out these very common, very easy to do kind of points. They're not the only points on the unit circle, they're just the ones that have nice values that work out really nicely with good triangles. All right. So here we've got trigonometric function values of an angle theta. Values of trigonometric functions at an angle theta, we're going to start working that. So let P of x be any point on the terminal ray of an angle theta in standard position other than the origin, and we're going to let R be that radius of our circle there. And then when R is greater than, so let R be the radius, we're going to let R be greater than 0, and then what happens is our sine is, I kind of wrote this on the first page, but it's going to be y over the radius, and this one's going to be x over the radius, and this one's going to be the same. It's going to be y over x, and this one's going to be 1 over the sine, so it's going to be r over y. This one's going to be r over x, it's the reciprocal of cosine, and this one's going to be x over y. So those two aren't going to change. But basically what happens is, as we scale out to larger, as we scale out to different ones, we can actually get, we can still get these things, And even for larger circles than just a radius of 1, we can still use these because it'll scale down, where if we double the size of our circle, we double r, we'll end up with a y value that gets doubled, but then so does r, it gets doubled. So still, even here, when we're thinking of these as angles, they're going to all just kind of convert down to the values that were on the unit circle, rather than if we were out here with a larger circle, having to just kind of trace it back and say, all right, well, what were the x and y values? Those are going to stay the same. This will just be the 1 over y, and this is 1 over the x, the same as it was on that previous table that we did before, okay? And so what we're just kind of doing here is swapping out for thetas instead of that, okay? So let's take a look at this example here. It says, find the trigonometric function values. Suppose theta is an angle whose terminal side contains the point -1, 3. Find the exact value of the 6 trigonometric functions of theta. All right, so we basically have here is we have some point on some circle, right? What I do is I make up this circle, and it's the point -1, 3, which means I didn't draw this very well. Let me get a good circle. So let's draw a circle. Let's do this. Let's do that. And let's say that we're out here and we're at -1 and then +3. So let's call that this point here. Okay? This is -1, +3. So this is obviously not the unit circle, because the unit circle has a radius of 1, which means we're kind of stuck there. So what we could do is figure out what this radius is. And so the radius here, we'll do a capital R since it's not the unit circle, has to be the square root, just like we're doing the distance from the origin, which is 0, 0, out to that point. And that'll tell us the radius of that circle. And so we're going to do -1 minus 0 squared plus 3 minus 0 squared. And so that gives us -1 squared, which is 1, and 3 squared, which is 9, and we're taking the square root of this. So this thing has a radius of the square root of 10. Okay, so now we can go through and start finding our sine values, cosine values, and everything like that. So I'll look at cosine of theta, and from that previous page, remember, if r is not 1, then I can just use this right here, and it'll kind of work back for me. So I can do the x value, which is -1, over that square root of 10. And if we don't want to leave that radical in the denominator, this will be negative square root of 10 over 10, just by multiplying the top and bottom by square root of 10. Then I can do the sine value, and the sine value is going to be the y value over r. So that's 3 over square root of 10. Multiply top and bottom by square root of 10 to get it out of the denominator, and you have 3 root 10 over 10. And so you see how I can just use those same formula to figure out all of these things. Okay? So we're going to go ahead, and I think I'm going to stop there. I want you to finish up the tangent, the cosecant, the secant, and I'll fill it out in the notes for you so you can check, and the cotangent on this one, using the idea of just dividing by that r by finding that radius first. Okay?